Hi and welcome to Statistics Video 2. In this video we're going to review basic graphs and analysis, and we'll look at a range of simple graphs and how they're sketched and what they show. I will be introducing a couple of new terms into this video. In particular, I'll be talking about univariate and bivariate data. So univariate data is data that's based on a single variable, hence univariate data, and there are specific graphs that show univariate data. And then bivariate data is data based on two variables that are connected in some way. So we'll talk more about those. I'll also be using some of the language from the video that we covered last week, so just be prepared for that. So the graphs. First of all, we will talk about bar charts, and we will also talk about histograms. And these two are pretty closely linked, bar charts and histograms. And then I'll talk about dot plots. And dot plots are pretty similar to bar charts and histograms, but quite a bit simpler. And then I'll talk about pie charts and line graphs, and they're both a bit different. So let's have a look at bar charts. Bar charts represent categorical data, and they're usually based around a frequency on the y-axis, on the vertical axis there. This particular bar chart shows the score that people scored against the number of times that score was scored. So there were 5 people who scored medium, 5 people in this category, and 3 people who scored good, 1 person who scored excellent. And it's a pretty simple bar chart. It's pretty easy to show things neatly. Make sure that you've got your columns and or your axes labeled and have the values on there clearly. And that's a bar chart. Histograms, on the other hand, can contain information that is quantitative rather than qualitative or categorical. So histograms are a really good way of showing numerical data. You'll notice here that there is still typically a frequency axis, and again this is one based on score, but in this case you can see that 3 people, or 3 somethings, scored a 0 to 10, and so 0 to 10 is here. Now this is group data, so they could have scored 7s or 2s, or maybe there was a 2, a 7 and a 9. We don't really know, but we know there were 3 people in this group, and you can see that there's 3 people there. The axis here goes up in 2s. You don't have to go up in 1s, you can go up in 2s or 5s or 10s, as long as it's reasonable. I would avoid numbers that give difficult fractions and percentages to work with, so 3s and 7s, probably don't go up in those. But anything can be split nice and easily, so anything that has predominantly factors of 2 and 5 are usually pretty good. And I have a percentage frequency over the side here as well, which you can use because it's proportional to frequency, but it's not necessary. So this histogram doesn't have gaps in between the columns because it represents continuous or discrete data, and it's showing that every number is part of the data. Now in this case it's discrete data, and we have a 0 to 9 class interval, or a 10 to 19 class interval, etc. So the number 9 exists here, and the number 10 exists there. So there is kind of a gap, I suppose, between 9 and 10 that doesn't exist anywhere. But even so, we're looking at this as a discrete data set, and the numbers 0 to 9 all exist in that bar, and then the next possible number is 10. So that gap doesn't really mean anything. And with continuous data, that's obvious that we don't, or we shouldn't have a gap. And in this case, again, we should label both axes and have a title and make sure our scale is appropriate. Now, a dot plot is a really simple version of a bar chart and just uses dots. Sometimes a dot plot is called a pictogram, and you'll have pictures instead of dots. So in that example, you might have some data that is outlining the number of donuts eaten in particular cities across Australia, and you might represent the frequency as donuts, and donuts might represent 1,000 a day or 10,000 a day or something like that. So you might have pictures there as well, and media particularly like to use pictures so that they can make their newspapers look a bit fancier. Now a dot plot here doesn't have much information, doesn't have an axis or any information here. It doesn't need to have a vertical axis because the dots set out the vertical axis. So it is a really simple graph, but we have to make the assumption that each dot is worth 1 in this case, and I think that's a fair assumption to make because there's no other information there, and that's the best we can do. But sometimes you might have a key, so there might be a dot, and the dot might say means 10 people, and then you get a better idea of what the dots are representing, and that's a dot graph. And then we have a pie chart. Now a pie chart, which I call is a representation of pieces of pizza, and it represents a proportion of the data. So you can see the first one there, bus. Bus represents about about a third of the data. I can see that. And walk is about a sixth of the data. Now, I don't know if that's exact, but it looks like that's about the breakdown. Now, we don't know the context of this, but we presume it's some sort of how people get to work or how students get to school or some sort of transport piece of information. And we can see the proportions based on this graph that bus is the most common because it subtends the largest angle, and then car is the next most common because it subtends the next largest angle, and then walk and cycle, and then taxi last. So each of the angular components represent the size of the sectors, and that represents what proportion of the data that category represents. And this is obviously categorical data as well. Make sure that you include labels, so write bus on it, or you might use a color label. So you might say something like purple means cycle, etc. Okay, moving down, last of all we have line graphs. So a line graph is represented on two axes, and it usually represents bivariate data. By that I mean that it's data that is connected in some way. So we say here that Sunday the temperature was 25 degrees Celsius, and on Monday the temperature was 28 degrees Celsius, so on and so forth. So there's a connection between one set of data, set 1, and set 2. Sunday was this, Monday was this, etc. Now with a with a line graph, then usually on the horizontal axis it'll be a measure of time, and sometimes we call that a time series graph instead, but they're the same thing. You need to make sure we label both axes and give the chart a label, which we have done here. And in this case, you can actually see that whilst the vertical axis goes up in ones, which is fair enough, it doesn't start at 0. So in this case, we probably need to make that clear. And sometimes a little squiggly line can make that clear there, or something just to show that we're not starting at 0. Otherwise, we get a feeling just looking at this graph that the temperature on Monday was like 4 times or 5 times bigger the temperature on Thursday because it's right up here. But actually, it was just 19 to 28, which is not even twice as big. But the graph's a little bit misleading like that. Having it on a scale from 0 to 28, though, would be a little bit unreasonable. It would push all the data and make it look almost like a straight line, which is a bit problematic. So this is a fair graph. We have to make sure it's not misleading. And that's pretty much all the charts you need to know for this topic. There are other charts out there, and hopefully through just comparing and considering these ones, you'll get a better idea of how to represent them or how to read other charts as well.